Hello students, now we will discuss relation between roots and coefficients of quadratic equation. Relation between roots and coefficients. Let alpha and beta are the roots of the quadratic equation ax square plus bx plus c is equal to 0 and are given by alpha is equal to minus b plus square root of b square minus 4ac whole upon 2a and beta is equal to minus b minus square root of b square minus 4ac whole upon 2a. Therefore, the sum of the roots is given by alpha plus beta is equal to putting the value of alpha minus b plus square root of b square minus 4ac whole upon 2a plus putting the value of beta minus b minus square root of b square minus 4ac whole upon 2a. Now in the right hand side LCM is 2a, so alpha plus beta is equal to, in the denominator 2a, in the numerator we get minus b plus square root of b square minus 4ac plus within the bracket minus b minus square root of b square minus 4ac. Now opening the bracket in the numerator we get alpha plus beta is equal to minus b plus square root of b square minus 4ac whole upon 2a minus b minus square root of b square minus 4ac. Now square root of b square minus 4ac plus and square root of b square minus 4ac minus, they cancel each other. So we get alpha plus beta is equal to minus b upon 2a. Minus b become minus 2b is equal to minus 2b upon 2a. Now 2 and 2 cancel each other. So we get alpha plus beta is equal to minus b upon a. Let it be equation number 1. Or sum of the roots is equal to capital S is equal to alpha plus beta is equal to minus b upon a. This is the formula to find the sum of the roots from the quadratic equation. Let it be equation number 2. And the product of the roots is given by alpha into beta, putting the value of alpha minus b plus square root of b square minus 4ac whole upon 2a into putting the value of beta minus b minus square root of b square minus 4ac whole upon 2a, or alpha into beta become equal to minus b whole square minus whole square of square root of b square minus 4ac whole upon 4a square. 2a into 2a become 4a square, and in the numerator using the formula, because x plus y into x minus y is equal to x square minus y square. Here x is equal to minus b and y is equal to square root of b square minus 4ac, or alpha into beta is equal to b square, as minus b square become plus b square minus square root and square cancel each other. We get minus within the bracket b square minus 4ac whole upon 4a square. Now in the numerator open the bracket. This is equal to b square minus b square plus 4ac whole upon 4a square. Now plus b square minus b square cancel each other. So alpha into beta become equal to, in the denominator is 4a square, in the numerator become 4ac. 4 and 4 cancel each other, and also 1a cancel each other, and we get this is equal to C upon A. Alpha into beta is equal to C upon A. Or product of the roots is equal to capital P is equal to alpha into beta is equal to C upon A. Let it be equation number 3. So by this method we can find the sum and product of the roots directly from the equation. Now quadratic equation whose roots are alpha and beta. As alpha and beta are the roots of the given equation, therefore by factor theorem the required equation is x minus alpha into x minus beta is equal to 0. Now opening the bracket we get x square minus alpha x minus beta x minus into minus become plus alpha into beta is equal to 0. Now from the two middle term take minus common, so we get x square minus within the bracket alpha plus beta into x plus alpha beta is equal to 0. So this is the quadratic equation whose roots are alpha and beta. Here alpha plus beta is sum of the roots and alpha beta is product of the roots. So we get alpha x square minus sx plus p is equal to 0. X square minus sx plus p is equal to 0, where let it be equation number 1 where s is equal to alpha plus beta and is equal to sum of roots and p is equal to alpha into beta is equal to product of the roots. So by this method we can find the quadratic equation whose roots are given. Now consider an example. If alpha and beta are roots of the equation ax square plus bx plus c equal to 0, then find the equation whose roots are 1 upon alpha and 1 upon beta. Now solution is, the given equation is ax square plus bx plus c is equal to 0. Let it be equation number 1. Alpha and beta are roots of the above equation. Therefore, alpha plus beta sum of the roots is equal to minus b upon a minus coefficient of x upon coefficient of x square. Let it be equation number 2. And product of root alpha into beta is equal to c upon a, mean constant term upon coefficient of x square. Let it be equation number 3. Roots of the required equations are 1 upon alpha and 1 upon beta. Therefore, sum of the roots s is equal to 1 upon alpha plus 1 upon beta. Taking LCM, this is equal to beta plus alpha upon alpha beta, or it is equal to alpha plus beta upon alpha into beta. Alpha plus beta is minus b upon a and alpha beta is c upon a. Putting their values, we get minus b upon a whole upon c upon a. Now a and a cancel each other. We get is equal to minus b upon c. Therefore, sum of roots s we get is equal to minus b upon c. Therefore, product of the roots p is equal to 1 upon alpha into 1 upon beta, or it is equal to 1 upon alpha into beta. Putting the value of alpha into beta, we get 1 upon c upon a, or this is equal to a upon c. So we get sum of roots s and product of the root s. Hence the required equation is x square minus sx plus p is equal to 0. Putting the value of s and p, so we get, putting the values of s and p, we get x is equal to x square minus b upon c x. X square minus b upon c into x plus a upon c is equal to 0, or x square plus b upon cx plus a upon c is equal to 0. Multiply the whole equation by c, so we get cx square plus bx plus a is equal to 0. This is the required equation whose roots are 1 upon alpha and 1 upon beta. Now easy method to remember this: ax square plus bx plus c is equal to 0 is the given equation, and we want the equation whose roots are reciprocal of the roots of the given equation. Only interchange the coefficient of x square and c, that is, in place of a write c and in place of c write a. We get the required equation cx square plus bx plus a is equal to 0. So this is the method by which we can get the quadratic equation whose roots are the reciprocal of the given quadratic equation. Thank you very much.